This is the video tutorial in which I'll be solving the focused questions for the grade 12 advanced end of year exam. When you get your exam, the first thing you do, check the list of formula sheets that will be given to you in the exam. The first section of your formula sheet, which is this one, is related to topic 5 lessons. And the second part of the formula sheet is related to topic 6 lessons. And the third one, topic 8. There are no formulas related to topic 7. Let's begin now with subtopic 5.1. Define a reversible reaction. A reversible reaction is a reaction that can occur in both directions. That can occur in both direction. And I mean by both directions, the forward and the reverse directions. And I can identify a reversible reaction when I see this sign. So for example, nitrogen plus hydrogen giving ammonia is a reversible reaction because we see this sign in the middle. Now, when I say forward reaction, forward means in this direction. It's N2 plus 3H2 giving 2NH3. And when I say reverse direction, I mean by this the backward direction, 2NH3 giving 3H2 and N2. Take the characteristics of chemical reactions that reach equilibrium. A reaction that reaches equilibrium must be a reversible reaction. So the reaction should occur in two directions. And I should have, to start being reversible, products and reactants must be both present. So this is also another characteristics. Now, when a reaction reaches equilibrium, at this point, the rate of the forward reaction is equal to the rate of the reverse reaction. And I mean by this, I'll go back to the example I gave you. So the reaction, the speed of the reaction to give an H3 must reach a point that it becomes equal to the speed of the reaction at which NH3 will be giving H2 and N2. On the graph, we see it like this. This is the rate, and this is the time. This is the rate of the forward reaction. The forward reaction usually starts fast and then slows down. And this is the rate of the backward reaction. The backward reaction usually starts slow and then speeds up as products start to form. So this is gonna increase, and when both of the rates become equal at this point, at this time, we say that reaction reached equilibrium. Now, this is also a characteristic. They must take in an open system. That is wrong. For a reaction to reach equilibrium, the system must be closed to keep inside it the reactants and products without losing any of them. And especially if I have a gas, we don't want the gas to escape the system. The fourth point, the amount of reactants and products, they must be constant. We should, an equilibrium is reached when the quantity of reactants and products become constant, not equal. Do not get confused with this one. List the 3 characteristics of a reaction mixture must have to attain a state of chemical equilibrium. So as I mentioned, a reaction to reach equilibrium, it must be in a closed system or container, and temperature must not change, must be kept constant during all the process of the reactants, and I should have the reactants and products, they must be present. Without the formation of product and keeping the reactants, a system cannot reach equilibrium. So reactants and products must be present. Again, describe dynamic or chemical equilibrium. A dynamic equilibrium, it's a process where the reactants continues to give products, and at the same time the products will give back the reactants. So reactants continue to give products, and at the same time the products will also give back the reactants. So like as if there is no change, we reach a point where we don't see any change. And why we don't see any change in their quantities? Because the reactants keep giving the products, and at the same time, at the same rate, at the same speed, the products will give the reactants. Now there are two important points for a dynamic equilibrium. The concentration, the symbol of concentration is brackets. The concentration of reactants and products must be constant. And I will stress at the point that they should not be equal, they should be constant. Temperature definitely must be constant, and the rate, and I mean by rate the speed of the forward reaction, must be equal to the rate, and that is the speed of the backward reaction. In a state of dynamic equilibrium, we usually have two graphs. A graph for rate and another graph for concentration. Now, the rate of the forward must reach a point, so this is the forward, must be equal, or when it becomes equal to the rate of the backward, we start equilibrium. So equilibrium reached. So here it's the point where the dynamic equilibrium started. I'm gonna write equilibrium like this, started. Now for the concentration graph, I'm just gonna move it a little bit. Here's another graph showing the concentration. Now usually the concentration of reactants start from up and decrease until it becomes constant, and the concentration of products start from down and increase until it becomes constant. Sometimes the product can be like this. It doesn't have to be more than the reactants. It could be more or it could be less. So I'm gonna write here product, another type of product, and the one over here reactant. If you look at these two graphs, at this point equilibrium is reached because the lines became constant. Moving on, draw a dotted line in the diagram below to show the point at which equilibrium starts. Now, if I look at this equation, at this point, the lines became straight. It means that the concentrations stopped changing. So we take the first moment where these lines became equal, and that is over, I think it's almost over here. So this is the time where equilibrium started, at which dynamic equilibrium started. Relate the value of an equilibrium constant to the relative quantities of reactants and the products at equilibrium. So first, we're going to talk about the value of K equilibrium and relate it to the quantities of reactants and products while identifying, I'm going to do this part in red, while identifying the information provided by the value of K for a given equilibrium system at a specified temperature. So let's say I have an equation A plus B in equilibrium with C. In this case, K equilibrium at constant temperature will have a value. If the K equilibrium value is greater than 1, it means that this reaction is favored in the forward direction. Now, what does that mean? It means we get C more than A and B. So we can say that amount of products is more than the amount of reactants. And I'm going to explain to you again why. If I write the formula of K equilibrium, let's say that these are gases. K equilibrium is going to be the concentration of C over the concentration of A multiplied by the concentration of B. So if this fraction has a value above 1, it means I have C larger than A and B. And that's why we say the amount of products is more than the amount of reactants. Now, in another condition, if K equilibrium value is less than 1, and this means that this reaction is favored in the backward, in the reverse direction. And it means that we have A and B more than C. Or in other words, the amount of reactants is more, or favored is more than the amount of products. So again, if I look at K equilibrium, which is C over A multiplied by B, if this value is less than 1, it means what I have in the denominator, which are the reactants, is gonna be more than when I have in the numerator the products. Next, moving on to questions where they ask you to write the equilibrium constant. Now, I would like to point at the difference between Kc and Kp. Now, K equilibrium is Kc, and when they ask me to write the K equilibrium, I will use the symbol of brackets. But like you see in this question, when they ask me to write the expression of Kp, I'm gonna use the symbol P and not the brackets. Now, anything that is solid or liquid will not be included in the formula of K equilibrium. And K equilibrium, or Kc, is the concentration of products over the concentration of reactants raised to the power of their stoichiometric coefficients. So let's write the first equation. So Kc, or K equilibrium, is gonna be in brackets NO2. So the formula, you put it inside the brackets, and the coefficient, you put it as a power over N2O4. Again, this one, I'll put it inside the brackets. The power is 1, so it is like that. Now let's take the other example. Gas, gas, gas. It's all included in the K equilibrium expression. And by the way, all these examples are homogeneous equilibrium, because in the equation itself, I have only one type of physical state, which is the gas. So let's write the Kc for the second one. So here are the products. So I'm gonna start. I have two products. I have the H2. I'll put it inside the brackets, and the coefficient is gonna be raised as a power, multiplied by S2. So the whole thing is gonna sit inside brackets, and this one is gonna sit inside the brackets, which is the symbol of concentration raised to the power of 2. Now let's take the third example. Again, Kc, I have two products. They will be multiplied. I have H2O and I have CH4, and I have two reactants. So here it is the H2 raised to the power of 3, which is the coefficient over here, multiplied by CO. Now for this one, Kc is equal to, I have two products. I'm gonna put them in brackets, NO and H2O. Now H2O, I have 6 H2O, so I'm gonna write it as a power, and I have 4 NO, I'm gonna write it as a power. Again, the O2, a reactant, will be in the denominator, the 5 will be as a power, and NH3 will be over here, and 4 as a power. Now, for the last example, Kc is equal to hydrogen raised to the power of 4 multiplied by CS2 over CH4 and H2S raised to the power of 2. Let's continue. In this, are the reactions in the table in question 7 representing homogeneous or heterogeneous equilibria? As I mentioned, they are representing homogeneous equilibria, because in every equation, in every reaction, we have one kind of a physical state, which is the gas placed in brackets, the one I highlighted in yellow. Now, let's move on to the next question, where they ask us to write Kp. So again, as I said here, you are not going to use the brackets. So Kp is gonna be the pressure of C10H8. Now, if you look here, this is in gas and this is solid. So the solid will not be included in the formula. So the formula is simply the pressure of C10 H8. And as you can see here, the physical states are different. So this equilibrium is heterogeneous. Taking the other example, Kp. This is solid, so pay attention to this. It's not going to be included in the formula of Kp, and this one as well. So the Kp is simply the pressure of CO2. If by any chance for Kp you put CO2 like this, it is considered wrong because the brackets represent concentrations while P represents pressure. And here in this question, they want pressure. Again, when I'm writing Kp, I will include only the gas. Anything that is solid, anything that is aqueous, anything that is liquid will not be included in the formula of Kp. So in this case, I have pressure of hydrogen, this one, multiplied by the pressure of CO divided by the pressure of H2O. Next question, solid will not be included, it's only the gas. And if, for example, let's say, just as an example, if the gas is raised to, there's a coefficient, for example, that coefficient will be a power. So Kp over here is the pressure of CO2 over the pressure of CO. Let me give you an example. Again, just to show this one, let's say I have N2 plus 3H2 giving 2NH3. And all of these are gas. And they asked us to write Kp. So the Kp of this one, I'm just going to write it over here. And I'll start the answer of question 10 after this line. So Kp is going to be the pressure of NH3 squared. This 2 is going to be a power over the pressure of N2 multiplied by the pressure of H2 to the power of 3. Now, are the reactions in table of question 9 representing a homogeneous or heterogeneous equilibria? As I mentioned, they are representing a heterogeneous equilibrium because we have multiple or different physical states or more than one physical state. We have more than one physical state. You have in these equations the gas and the solid. So it makes this equilibrium homogeneous. Now let's move on. Next question. Given the equation CO gas plus hydrogen gas is in equilibrium with methanol, and the K equilibrium is 2.5 times 10 to the power of 2. Note that this K equilibrium is above 1, and if they ask me in which direction this reaction is favored, I will say it's favored in the forward direction. And we also know that the amount of product is going to be more than the amount of reactants. Now let's see what do they want in this question. They have given us the concentration of carbon monoxide 0.02 molar and that of hydrogen gas to be 0.5 molar. And they want us to find the concentration of this one. Now the expectations is to have a higher concentration for CH3OH higher than 0.5 and 0.02 simply because this K equilibrium is above 1. This is just a tip so that you are sure of your answer. So first of all, I'm going to write the equation, and it is the concentration of CH3OH over the concentration of CO multiplied by the concentration of H2 raised to the power of 2. Now, since we have K equilibrium, I'm going to substitute. So 2.5 times 10 to the power of 2 is equal to CH3OH over the CO is 0.02 and the hydrogen is 0.5 raised to the power of 2. Do not forget the power if there is any. And solving this with our calculator, we get the concentration of CH3OH to be equal to 1.25. Now, never forget the unit. It is capital M, molar, or you can simply write mole per liter. My advice, just follow the lead of the question. So here it's written capital M, just write it capital M. What is now? Moving on to topic 5.2, the Le Chatelier's principle. What is the result of removing one of the products from a reaction at equilibrium? Now I'm just gonna write a system at equilibrium and I'm gonna give you this method, this technique. Always draw water tanks next to your question. And these tanks are filled with water. And we're gonna treat the stress given to be like water added or water removed from the sides of this tank. So in this question, they are saying we are removing one of the products. The product is B. It means we are in this tank. So if I am removing from this tank some of the water, let's say the level of the water reached here, the water in the tank is gonna move in this direction to re-establish the balance or the equilibrium again. So in this case, our equilibrium is gonna go to the right. So in this case, we're gonna say in the right. Now, one important thing, when they tell you removing or adding a reactant or a product, make sure that the product is not liquid or not solid, because if the reactant or product was liquid or solid, then the answer must be no effect. So here I'm just gonna put this as gas. So what is the effect on equilibrium of changing the volume and the pressure of an equilibrium system if the number of moles of gas is the same for reactants and products? Now let's give another example. If I have 2A giving B plus C, and this is gas, this is gas. Let me put again D. This is gas and this is solid. When they ask you about volume and the pressure, you are going to think and count the moles of gas only on both sides. So here on this side, I have 2 moles. And here on this side, this one will not be counted. I have 1C and 1B, so I have 2 moles. That's what it says in the question. They gave us an equilibrium in which the number of moles of gas is the same for reactants and products. In this case, any increase or a decrease in the volume or the pressure is not going to have any effect on the equilibrium, because either sides are not going to affect or influence the pressure inside the container. Determine how the following change affects a system in equilibrium. Write a sentence that includes the term in parentheses decrease in volume. So let's say for this question I'm just gonna give you again the same example, but this time I'm gonna say I have 2A gas giving 1B gas and D solid. So on this side I have 2 moles of gas, and of course the solid I'm not gonna count it, and I have 1 mole. So any change in the pressure is going to affect the equilibrium, and the equilibrium is going to shift in the direction that relieve the stress. So for example, if I have a decrease in volume, a decrease in volume means an increase in pressure. So when pressure is increased, the equilibrium will shift toward the direction that will relieve the stress. And what does that mean? Relieve the stress. I have 2 moles versus 1 mole. If there is an increase in the pressure, the equilibrium is going to go forward towards the less or the fewer moles of gas, because with less moles of gas, pressure will go back to decrease itself because we increased it, so the pressure is going to go back to its original equilibrium and decreases itself. So here equilibrium will shift towards the side with less moles of gas. Now, this is another type of question, and instead of saying right, equilibrium shifts to the right, you're going to say blue. And instead of saying the equilibrium is going to shift to the left, you are going to say pink. So cobalt 2 hexahydrate ions, this one, is going to forms a pink solution. It reacts with chloride's ion, Cl-, to produce tetrachloride ions, COCl4, and water according to the following equilibrium. Now in this question, they are asking me, explain the effect of a catalyst on an equilibrium system. A catalyst has no effect on shifting the system to the right or to the left. It has no effect. Simply, a catalyst will make the system reaches equilibrium faster. So a catalyst will only speeds up the reaction. Now let me show again the equation and solve the questions over here. Adding few drops of NaCl. Now when I look at NaCl, I know from topic 7 that the Cl has an oxidation number of -1. And when I look at the equation, I can see over here Cl-. So again, I'm gonna draw the water tank and answer the question using this water tank. So I have water on both sides. They said adding NaCl or adding Cl-. When I look at the equation over here, I'll see that Cl- is on the left. It means that Cl- is on this side. And we just decided to add more. It means we have more of the Cl on this side. So I'm gonna draw just a little bit more. How will the equilibrium shift if I have more water on this side? The water is gonna go towards the right. to go back to the balance or the equilibrium state. And going to the right will produce blue color. So instead of saying right, you're going to write blue color. Now, adding a few drops of CO H2O 62 plus. So they are adding from this one. And again, COH2 62 plus is on the left side of the water tank. So again, as if I added more water on this side, so the equilibrium is going to shift in the right direction to release the stress or to cancel the stress. So again, you're going to say blue. Now, adding drops of COCl4. I'm gonna erase this and again draw this water tank and I have the water in the same level. When they tell me that they have added COCl4, COCl4 is on this side of the water tank, or as if the water is on the right side, and we just added more of it. So here I'm just gonna have more of COCl4 on this side. And if you have more, how will the water move in the tank in order to re-establish equilibrium? The water is gonna go in this direction. It's gonna go in this direction to go back to equilibrium. And this direction means left, and left means pink. Increasing the pressure. As I mentioned in the previous question, when we discuss pressure, we only count the mole of gases. I don't have a gas, I don't have a gas, I don't have a gas, and I don't have a gas. So in this equation, I have 0 mole of gas versus 0 mole of gas. And in this case, increasing the pressure or even decreasing the pressure in this system has no effect. The color is not gonna change. Now again, another question, increasing the pressure. Whenever they ask about pressure, we count the moles of gas. I have here 1 gas and I have 2 gas. So I have 3 moles versus 1 mole of gas and another 1 mole of gas versus 2 moles. When we increase the pressure, the equilibrium is gonna go in the direction of fewer molecules, and fewer molecules means in this direction. So we're gonna answer equilibrium will shift to the right. Now another question, increasing volume. You know that pressure and volume are inversely proportional. So immediately flip the question in your mind. Increasing volume means decreasing pressure. So at this point, when the stress is applied and the stress is less pressure applied, the equilibrium is going to shift in the backward direction towards the more mole, towards the 3 mole and not the 2 mole, to increase back again this pressure, to release this stress. So our answer in this case is going to be to the left. Moving to topic 5.3, there's only one question. For the reaction X plus Y, note that Y is solid. It's not going to be included in the formula of K equilibrium. The concentration of X is 1.20 molar and the concentration of Z is 3.60 molar. Calculate Kc. So let's write the equation. Kc is Z in brackets, and this 2 will be written as a power over X in brackets. Of course, I'm not going to include the solid. Now I'm going to substitute. It's a 3.60 squared over 1.20. Plugging this into our calculator, we obtain 10.8. Kc and Kp has no unit. There's no unit for the K equilibrium. Now let's start with the questions of subtopic 6.1. And this topic is about acids and bases. Describe the relative amounts of hydrogen ions. This is hydrogen ion, and when they talk about amounts, it means concentration. And hydroxide ions, that is OH minus, in a neutral solution. Now, in a neutral solution, it means that these ions are equal to each other. I'm just gonna put the key points over here. If I have acidic, H plus is gonna be more than OH minus concentration. If I have basic medium, H plus is gonna be less, or you're gonna say OH minus is more. So H plus is gonna be less than OH minus. Or I'm not gonna confuse you, I'm just gonna write OH minus is gonna be more than H plus. Now only in neutral medium, at this point, H plus is going to be equal to OH minus, and specifically it's going to be equal to 1.0 times 10 to the power negative 7. If I show you the formula sheet over here, I have Kw and I have H plus and OH minus multiplied by each other, giving me 1 times 10 to the power negative 14. If they are telling me that these two are equal, it means I'm gonna say 1 times 10 to the power negative 14 is equal to H, and I'm gonna substitute with H plus for OH minus because they are equal in neutral. So I'm gonna say squared. Now if I wanna solve for H plus, I'm gonna say square root of 1 times 10 to the power negative 14, and that is 1 times 10 to the power negative 7. So this is why, this is from where I got this number. Now I'm gonna erase it and continue with the next question. Where is it? Yep. Write the formula of the following acids and list if it is a binary or oxy acid. Now, binary acids, their name always starts with hydro, then the name of the nonmetal ended with ic acid, whereas oxy acids are the acid containing hydrogen, an element, and oxygen with them. And usually their name is not going to start with hydro. We immediately name the non-metal, and we either end it by like ic or us acid. Now you're gonna see I have here hydrobromic acid. Because they said hydro, it means this is a binary acid. Now, what will be the formula of hydrobromic acid? Bromic is the Br, the bromine. Now, unfortunately, the periodic table that you have does not include the name, but I want you to go to the exam and memorize the name of these nonmetals, because you need to, if they gave you HF, you need to say hydro fluoric acid, hydrochloric acid, hydrobromic acid, and hydroiodic acid. And also in the periodic table, make sure also you know the name of these metals if in case you wanted to name a base. I'm going to give you an example of a base when a question about base will come. So hydrobromic acid is HBr. Again, hydroiodic acid. Because I see hydro, it's a binary acid. And every acid must start with hydrogen to be an acid. And iodic is I. Sulfuric acid, there is no hydro in it, so that is an oxy acid. And you need to know the formula of this oxy acid, and it is H2SO4. There will be other acids that you need to memorize. Just stick to this list. This is HNO3 nitric acid. This is H2SO4 sulfuric acid. This is H2CO3 carbonic acid. H2PO3 this is phosphorus acid. Remember I told you the oxy acid, they could end in the termination of ic or us acid. Now the next one is acetic acid, CH3COOH, that is acetic acid. HCl is hydrochloric acid. This one, hydrobromic acid, hydrofluoric acid, hydroiodic acid. Now, when it comes to the name of bases, remember that this is ammonia, this is sodium hydroxide, this is lithium hydroxide, this is potassium hydroxide, and calcium hydroxide. And this is why I told you in group 2, 1 and 2 elements, memorize the name of the elements over there. So in case you got a question to name a base, you will know the formula or the name of that base. What is the formula of calcium hydroxide? That is calcium, and hydroxide is OH. Now, because calcium belongs to group 2, you're gonna have 2 hydroxide in its formula. Now, list the type of acids. Also, when they ask me the type of acids, I'm gonna list them as monoprotic, this one, monoprotic, because I have one H in it. An H is called a proton, so that's why we call it monoprotic. The second one is having 2 hydrogens, 2 protons in it, so I'm gonna say diprotic. The third one is having 3 protons in it. It is triprotic acid. Another question, label the acid, base, conjugate acid, and conjugate base. Now, since in this question they gave us 2 model of questions, one particulate diagram and one as an equation, be ready that in the exam they might give either one of those. Now, when we look at acid base, conjugate acid, conjugate base, I want you to know that the word conjugate comes for the species after the arrow. So this is a conjugate. I will tell you in a minute conjugate what. And this one as well is a conjugate, and it's after the arrow. Now, these two are going to be acid or base and base. Now, you just identify one substance that you know on the equation. For example, we all know that OH minus is the symbol of a base. the OH minus. So in this case, this one is going to be classified or labeled as a conjugate base. Now, if this is a conjugate base, then the one next to it is going to be a conjugate acid. I cannot have two conjugate acids on one side or two conjugate base on one side. They have to be alternating, one acid, one base. Now, this conjugate acid is coming from this molecule, which is now going to be called a base. So here you said conjugate acid, here you're going to write the opposite. And if this is a base, then the one next to it is an acid. Now there is another way to guess the conjugate acid, conjugate base, acid and base, and it is by looking at the migration of hydrogen ion. If you look at this molecule, you're going to find that this one has 3 hydrogens. And if I compare it to the one obtained over here, I'm going to see that now it has 4 H's. And an acid and a base, according to Bronsted, is a proton acceptor. It accepted one more hydrogen. That's why this is a base. And an acid, look at this one. It had 2 hydrogens and now it only has 1. So it acted as a donor, and this one it acted as an acceptor. The donor is always an acid, the acceptor is always a base. Now let's look at this example. Another example, but this time it's in form of an equation. For instance, I know that OH minus is a base, so I'm going to write base, and these two on this side are going to be called the conjugate. The conjugates. Now, if this is a base, then this is an acid. And you must know that HNO3, the nitric acid, is an acid. And this is a base. Now, what comes from this one is NO3 minus. It is obtained when HNO3 donates its proton to this molecule, to this compound. So this is an acid, and therefore this one is a conjugate base. Again, this is a base because it accepted a proton. So if that's a base, look at it here. Now it has 2 hydrogens, and that's a conjugate acid. On to subtopic 6.2. What is the difference between a strong and a weak acid? So the main difference between a strong and a weak acid is in the degree of ionization. A strong acid ionizes completely in water. Ionizes completely in water. Whereas a weak acid barely ionizes in water. It means partially, I can write partially ionizes in water. Now, what does this mean? If I have an acid, like for example HCl, it's a strong acid, it's a one-way direction reaction, and all of the HCl will ionize into H plus and Cl minus. But if I have HF, which is a weak acid, only a small portion of this HF acid is going to ionize and give me H plus and F minus. Now, the most important thing when you look at the equation of a strong acid, it's a one-way direction. And when you look at the direction of, when you look at the reaction of a weak acid, it must have these 2 double-sided arrows, the reversible arrow. Now, a strong acid will form strong electrolytes, and the concentration of H plus formed will be large and form large amount of H plus ions. because it fully ionizes in water. Whereas the weak acid, it's gonna have weak electrolytes, and I mean ions, and that's because it has a lot of H plus formed. So here it forms large amount, and for the weak acid will produce small amount of H plus. Now, of course, when it comes to the conductivity, a strong acid is a strong conductor or a good conductor, a strong conductor of electricity, but a weak acid is a weak conductor of electricity. And all of these properties are related to the strong acid being completely ionizing in water and the weak acid partially ionizing in water. Describe, again, another question, describe the strong acid and the weak acid. So again, this is the same question almost mentioned in a different way. Now I'm gonna give you the list of strong acids to keep in mind. List of strong acids, you have HCl, you have HBr, HI, and we have an oxy acid, the nitric acid, the sulfuric acid, and the perchloric acid. Now in your answer key, they're also mentioning the HClO3, but the most common one are these ones that I mentioned. Now you can find Cl and Br and I under each other in group 17 of the periodic table. So just remember to add H to them so that you can get the list of strong acid. Whatever that you did not memorize in this list, and it is an acid, definitely this is going to be a weak acid. So again, in the strong acids, as I mentioned, strong acids, they form strong electrolytes. Okay, I'm gonna make it in form of a table. Strong acid, and here I'm gonna write weak acid. So the first main difference, full ionization, partial ionization. That's first. In the equation of the ionization of a strong acid, we use this type of arrow. In the ionization of a weak acid, we use the reversible arrows. Strong acids form strong electrolytes, and that's why they are good conductors of electricity. Whereas the weak acid will form weak electrolytes. Now, if you are wondering what does electrolyte mean, means ions, because simply weak acid will not produce a lot of ions. So it will form weak electrolytes, and it's a weak conductor of electricity. The concentration of H plus in strong acids is large, whereas here it is small. Now if I want to talk about the pH of a strong acid will range between 0 and 2, whereas the pH of a weak acid will range between 3 until below 7. Yeah. Now some examples of weak acids, the most common one, acetic acid, HF, hydrofluoric acid, carbonic acid, hydrogen cyanide, etc. I don't recommend to memorize the list of weak acids, but focus on knowing the list of strong acids. Wherever that is not in this list is going to be a weak acid. Which equation represents the ionization of hydrobromic acid? Hydro means I have a binary acid, and a binary acid, it's H and an element. Now since the element here is bromic, this means this is bromine, so this compound is HBr. Now in this one, I think I erased the answer key of this one. There was two equations, HBr, H plus and Br minus. So this is the ionization of a weak acid. This is the ionization of strong acid, and that's the answer. Write the expression of Ka for the given reaction. Now, I want to mention that Ka is called the acid ionization constant. Just like what you saw in topic 5, we saw K equilibrium. In this lesson, we're going to call it Ka because we are dealing with acids. If we are dealing with bases, it's going to be Kb. Now, since the acid is an acid that partially ionizes in water, it's going to have a K equilibrium that is less than 1 because it's going to barely give me products, and the majority is going to remain unionized. So majority will remain unionized, and therefore the Ka of any weak acid is a small value, less than 1. Now, just like you learned as well in topic 5, when you write the K equilibrium expression, but in this case we are going to call it Ka, it's the products concentrations over the reactants concentration, and we do not include liquids. So it's going to be in this form. Now, when they give you an acid, the given acid, you always put it over here because it's the one we are checking its ionization. And since it is an acid, you may write H3O plus, or you may write H plus. Now, always what you put up in here is going to be the conjugate acid, the conjugate base of this acid. So here's the acid, and here's the conjugate base. And a conjugate base, it means you remove one H from it and you downgrade the charge. So this one was negative. When you remove another H, it's going to become -2. Or I can write the equation of Ka by, instead of H3O plus, I can put H plus and CO3 2 minus. I'm just going to give you just another example. You look, these are all weak acids, and I know that they have Ka that is less than 1. If, for example, in any of those acids, they ask me to write the Ka of any of those acids, let's say they ask me to write the Ka of hydrocyanic acid, so I'm going to put HCN in the denominator, and I'm going to put H plus. You know this one, I'll just separate it. I'm going to put H plus, and the rest would be Cn with a minus. Other example. Now, define the ionization constant. The acid ionization constant is Ka. It is the equilibrium. It's the equilibrium constant expression. It's the equilibrium constant for the ionization of an acid, and specifically of a weak acid. It kind of shows the degree of ionization of an acid. It shows the degree of the ionization. And what do I mean by this? the smaller the Ka value, the weaker the acid. And this leads us to this question. Here in this question, they are showing you a list of acids with their ionization constant or dissociation constants. And the question says which one is the strongest, which one is the weakest. If you look at the value of Ka, this is very small, and this is also very small. This is a bit larger, and this is much larger. But all of these values, all of the given Ka are less than 1, which means that all of these given acids are weak acids, which means that all the given acids are weak. But of course, some acids are weaker than others, and some acids are stronger than other acids, but still, in general, they are weak. So the weakest among the list, I'm gonna take this one and this one. These two acids, they have Ka to the power times 10 to the power negative 10. So I'm gonna go and compare the number. 1.6 is less than 6.2, which means the weakest acid is HOC6H5. So that is the weakest. Now, which one comes next? Definitely HCN. Now, which one comes next? It is the hydrazidic acid, HN3, and the strongest in the list, but still it is a weak acid, it's the chlorous acid. So the strongest acid among all weak acids is HClO2 given in this list. Moving on with the questions, compare strong and weak bases. Again, strong and weak bases, they behave just like strong and weak acids. Strong base ionizes completely, full ionization, whereas a weak base, partial ionization. Of course, a strong base is a good conductor, a strong conductor of electricity, whereas the weak base is a weak conductor of electricity. A base will produce a lot of OH minus called hydroxide ion, and here we'll have less concentration of OH minus. Now, which are the bases that you should always remember? If you go to your periodic table, you have group 1 and group 2. In group 1, it starts with hydrogen, lithium, sodium, potassium, rubidium, and cesium. Or cesium and rubidium, just let me check. I'm not. So here, these are the metals of group 1. Yeah, rubidium and cesium. And down in here, these are the metals of group 2. So if you take the metals of group 1 and you add OH to each one of them, you're gonna get a strong base. Now for group 2, you cancel the first two and then you add OH, but because it is group 2, so you're gonna have 2 hydroxide ions. Now in those ones over here, you're gonna have 1 OH, and like this you will get the formula of all strong bases. So all of these are strong bases. Remember, in group 2 you're gonna put 2 hydroxide ions. So memorizing the formula or the list of strong bases should be easy. You just need to remember, I take elements of group 1 or elements of group 2 and I'm gonna add either 1 OH hydroxide or 2 hydroxide ions. Now for the naming is easy. Remember that OH is called hydroxide. So if I have an AOH, that's sodium hydroxide. If I have CaOH2, that's calcium hydroxide. If I have KOH, that's potassium hydroxide. Now, whatever that is given to you in the question and that does not belong to this list, it will be a weak base. So let's write here. Write the type of the base below. Wait, I'm just gonna write also the list here so that you can remember it. I have beryllium, I have magnesium, I have calcium, barium, and strontium. So for group 1, of course not the H, it's gonna be 1 hydroxide. And these two, they form weak bases, while the last 3 strong bases. So whatever is given to you, if you know this list, then you will be able to categorize them as a strong or weak. KOH, here's KOH, that's a strong base. NH3 and CH3 and H2 are not in this list, so both of them are weak base. Now you just need to remember that an acid will have an H in it, but these bases, you remember you taught in term 2 the amines, it's a carbon and nitrogen and hydrogen group, or nitrogen and hydrogen group. Amines are basic, so be careful not to mention and say that this is a weak acid. It is a weak base. Now moving on to the next subtopic in our focused questions, and it's the part where you have to get your calculator and do some calculations. Now in your formula sheet, this is the section where you are going to use the calculations for topic 6.3 topic. These are the formulas. Okay, so I'm gonna write again the formulas over here and I'll tell you how to use them. So minus log H plus to calculate the pH. Just like I have a formula for pH, I have another formula same for pOH, which is not written in your formula sheet, but you can write it of the same style of pH. Now I also have Kw is OH minus multiplied by H plus, and that is equal to 1.0 times 10 to the power negative 14. And anytime pH and pOH, you add them together, you get 14. Make sure you know the name of each. This is called H plus, or they might refer to it as hydronium ion, because you know pH also can be written minus log H3O plus. So whether they say if the concentration of hydronium ion or concentration of hydrogen ion, we are referring to H plus and H3O plus. If the concentration of hydronium ion in a solution is 2.0 times 10 to the power negative 5, calculate the concentration of hydroxide ion. Do not go to the exam without knowing the name and the formula. This is hydroxide ion and this is hydronium ion. So I have H plus or hydronium ion and I need to find this one. So Kw is the right formula. So Kw is OH minus multiplied by H plus, or you can write it as H3O plus. So H plus or H3O plus, it's the same. And this is equal to 1.0 times 10 to the power negative 14. Now let's keep this as OH minus and let's substitute this with the value over here. 1.0 times 10 to the power negative 14. Plugging this into your calculator, you're gonna get OH minus to be equal to 5.0 times 10 to the power negative 10. Now never forget the unit. Here's the unit, molar. If a solution has a pH of 1, what is the pOH? Here's the formula that connects pH and pOH. So pH plus pOH equal 14. So if I have 1, the pOH is going to be 13, equal to 13. pH and pOH has no unit because it's a scale. Again, another question, what is the pOH of a solution having a pH of 6? So 6 plus pOH equal 14. So the pOH over here is going to be 8. No unit for pOH. The H plus in a neutral solution. At the beginning of subtopic 6.1, I mentioned when I have neutral solution, H plus will be equal to OH minus and will be equal to exactly this concentration. So if I have a neutral solution, here's the answer. Relate the acidity and the basicity of an aqueous solution to the hydronium and hydroxide ion concentration and pH. I'm just going to give you a hint to organize your ideas. H plus and OH minus are inversely proportional. Like one increase, the other one will decrease. H plus and pH are also inversely proportional. So H plus is inversely proportional to everything. Now, let's take the OH minus. Again, OH minus and H plus, as I mentioned, are inversely proportional. But OH minus and pH are directly proportional, meaning if OH increase, pH is gonna increase. Now let's answer the question. How do they relate to the acidity? If I have an acid, I'm gonna make a table, and if I have a base. If I have an acid, the pH is gonna be less than 7. If I have a base, the pH is gonna be above 7. Now if I have an acid, I'll have H plus more than OH minus. If I have a base, I'll have OH minus more than H plus. Now in a neutral, what do I have in a neutral? In a neutral, pH is going to be equal to 7 and H plus is going to be equal to OH minus, and it's going to be equal to 1.0 times 10 to the power negative 7 molar. So keep that in mind. So this is how I related the acidity and the basicity, but I also added the neutrality of an aqueous solution to the hydronium and hydroxide ion concentration. This is what they want. They want to know which one is higher, which one is less, and related to the acidity, saying if pH is less or above 7. Use the following information to answer questions. The table below shows the information about 5 different solutions. While reading the question, I paid attention to this one. OH minus is equal to this value. As I told you, you need to remember this value. This means that the pH of solution N is 7, and that's neutral. So here they are asking me about a neutral solution. I'm gonna say N, or I'm gonna say option D. Now, this one is 3.1 pH. Here the pOH is 3.1. So I'm gonna calculate the pH and say 14 minus 3.1, and that is gonna be 10.9. So the pH is here 3.1 and here it is 10.9. That's acidic, that's basic. Now let's continue with the rest. So I analyzed solution L, I analyzed solution N, I analyzed solution O. I still have K and M. If I have OH minus to be 2.0 times 10 to the power negative 5, I can plug this into the formula of POH minus log OH minus. So in here, I'm gonna write 2.0 times 10 to the power negative 5. And I'm gonna get a POH of, so here, minus log. It's gonna be 4.7. So if the POH is 4.7, therefore the pH is 14 minus 4.7. I'm referring to this formula. So 14 minus 4.7, and the answer is 9.3. So I analyzed solution K. Solution K is basic. So K is basic, L is acidic. This one, I'm just gonna do it here. pH equal minus log H plus. So instead of H plus, I'm going to substitute. And the pH is gonna be negative 2. The pH is 1.7. So this one again is acidic. This is neutral. And this is basic. So let me just put them here. K pH is 9.3. L pH is 3.1. M, solution M, pH is 1.7. Solution N, it's neutral. And solution O, the pH is 10.9. So the most acidic is the one having the lowest pH. That's solution M, means option C. The most basic, it's the one with the highest pH. So that is solution O, it means option E. Now, the least basic solution. The least basic solution means what? Least basic means most acidic. So we already answered this question to be solution M, option C. Moving on with the question. Calculate the pH of a solution if the concentration of H plus is 1 times 10 to the power negative 4. Here's the formula. pH is equal to minus log H plus. So it is equal to minus log 1 times 10 to the power negative 4. That is equal to 4. No unit for pH and for POH. A solution having H plus, this is the concentration, what would be the OH minus? So I'm gonna use the formula of KW, which is H plus multiplied by OH minus equal to 1.0 times 10 to the power negative 14. So I'm going to substitute and the concentration of OH minus is going to be 1.7 times 10 to the power negative 10. Do not forget the unit, molar, just like the one over here. If the concentration of H plus is 1 times 10 to the power negative 5, what is the POH? This is a 2 steps answer. So first they gave me the H plus but they want the pOH, not the pH, they want the pOH. So first, we'll get the pH through this formula. And after we found the pH, we're gonna use this formula. So let's begin. Here, it's minus log 1 times 10 negative 5, that is 5. Now, I'm gonna use this formula. pOH plus 5 equal 14. So pOH equal 9. What is the relationship between pH and pOH? This formula, you must remember, it's in your formula sheet, and you need to use it if you need it in your calculations. What is the relationship between H plus and OH minus? That is Kw. It is equal to 1.0 times 10 to the power negative 14 at 25 degrees Celsius. Now, if you mentioned 25 or if you did not, that's okay. But usually the value of Kw is constant at this temperature. If the temperature changes, it's gonna change. But luckily, what's included in our KPIs is only the Kw at this temperature. The diagram below shows the pH of 3 different solutions, W, X, and Z. Answer the questions. Now, before I look at the questions, I have a pH above 7, that's a base. Below 7, that's an acid. Above 7, that's a base. Which solution is more basic, W or Z? Of course, we're gonna choose the one with higher pH. So it's gonna be solution Z. Based on the pH values, classify them as acidic, basic, or neutral. So W and Z are the basic, and X is the acidic. Now, finally, the last lesson or subtopic in topic 6 is the 6.4. Define neutralization reaction. Of course, something to neutralize. It's when the acid and the base cancel each other or neutralizes each other. So, a neutralization reaction. So the definition, I'm gonna write it over here. It is a reaction where acid and base neutralizes each other. What do I mean by neutralizes each other? I mean they react with each other to produce salt and water. That's the definition. Now, write the neutralization equation, and they want the complete ionic and the net ionic. So, the complete ionic and the net ionic. Now, the net ionic is an equation that I told you about. It's always the same equation, no matter what acid or base they give us. And if this question changes, the net ionic is not going to change. It's always H plus and OH minus in equilibrium with H2O. H2O is liquid, this is aqueous, and this is aqueous. Or you may want to write it like that. H3O plus and OH minus, but in this case, you're going to write 2H2O liquid. Now, when we talk about the complete ionic equation, I'm going to give you a very simple method to write the complete ionic equation. You take the acid first, and then you take the base. And acid is H plus and Cl minus when it ionizes, and the base is Na plus and OH minus. Of course, I'm using this type of arrow because HCl and NaOH are both acids, are both strong. So when they ask me to write the complete ionic, I'm gonna take those and add them together. So I'm gonna take H plus and Cl minus and Na plus and OH minus. Now let's go back to the definition. When I said that an acid reacts with a base, they neutralize each other to produce salt and water. So let's now form the water. These two, they form the water. That's H2O. So I'm done with these two. I already made out of them water. Now what remains over here is Na plus and Cl minus. So you copy them as they are. Na plus and Cl minus. Now if you wrote Cl minus then Na plus or H2O at the end, it doesn't matter. As long as after the arrow you write this. Let's take another example. Here I have another base with another acid. As I told you, the net ionic, whatever the question is, it's not gonna change. So the net ionic is H plus NOH minus. Honestly, I always prefer this equation instead of writing H3O plus because it's much easier. And it's gonna give me H2O liquid. Be careful not to forget the physical states. You will be penalized with marks if you do not put the physical states. Remember, water is the only one liquid. It's always liquid. Now let's put together the ionization of KOH and HBr in order to come up with the complete ionic equation. So KOH is gonna give me K plus and OH minus, and HBr it's gonna give me H plus and Br minus. So now let's use these ions in order to write the complete ionic equation. So K plus, OH minus, H plus and Br minus. Now again, these are strong acid, base and acid, so the equation is in one direction. Also this one will be in one direction because all of these are strong. So as I said, in the acid and the base, when they react with each other, I get the water and I get the salt. So let's form the water. These two are gonna give me water. So here we go, H2O liquid. So I'm done with these two, and these two ions remains. I'm just gonna copy them as they are. So K plus and Br minus. Now, titration, moving to the topic of titration. This is very important to remember. The difference between the equivalence point and the end point in a titration. When you are doing a titration, you start titrating an analyte with a titrant. You start titrating an analyte with a titrant, and you put an indicator over here so that when the indicator changes color, you know that you ended, or the titration must stop. This is called end point. The titration should end. It ended. So the end point in the titration is when the color of the indicator changes, telling you to stop, changes and persist, and it should be a faint light color. So a faint light color. So whenever I see this change, it means stop, and this is the end of the titration. Okay, and usually we obtain this color change slightly, like really slightly, after the equivalence point. Now, equivalence point, what does it mean? The word equivalence, it's coming from the word equal. Equal. Who's equal? It's the point where H plus, we're talking about acid and base, where H plus moles, or you can say N of H plus, the mole of H plus, became equal to the mole of OH minus. So the acid and the base, like you have an acid down in here, and you started adding a base. At a certain point, you're gonna add base as much as you have acid down in the conical flask. So when they are equal, we say that we reached the pH, we reached the equivalence point. Now, usually the equivalence point can be found from the graph. And yeah, it's found from the graph. It's gonna have three values, either above 7 or below 7 or equal to 7. Now, let's move on to the next question, and I'm going to explain what I said about above or below or etc. Now, the titration type. In your KPI, you only have two types of titration. The titration of a strong acid with a strong base, and the titration of a weak acid with a strong base. So I'm going to write it over here. Titration of strong acid with a strong base. Remember, the order is very important. It's wrong, or it's different if you say strong base with a strong acid, because this KPI is not included. We only have the acid with the base. It means here in this beaker, in this conical flask, I have the acid, and on top of it, I am adding a base. And the other type of titration that is included in your KPIs is the weak acid with a strong base. Now, let's take some examples. Strong acid with a strong base. Go for the simple examples. Let's say HCl and NaOH. So what's the salt formed? It's NaCl. And because this is a strong acid with a strong base, so the pH at equivalence point is going to be equal to 7. And what is 7? 7 is neutral. So this salt is neutral. Now, if I have a weak acid with a strong base, I'm just going to take an example, HF and NaOH. What is the salt? It's NaF. Now, because this is a weak acid titrated with a strong base, the pH at equivalence point is going to be above 7. What does above 7 mean? It means basic, because this salt is basic. Now, in your answer key of the focused question, they used a different salt, which is CH3COONA. So I'm going to give you this example. I have a weak acid, CH3COOH, and a strong base, NaOH. Now, exceptionally, this acid, here is the acidic H plus, and here's the OH minus. So what I'm gonna get a salt of CH3COONA. Now you're gonna ask me why you didn't write it like this. I'm just following the order here. Here H comes after and Na comes first. So In this one, I just removed the H and I replaced it with an A. So here's the salt. Now, I don't think if you wrote this formula of salt, they will consider it wrong, but still, preferably, this is the right formula. Now, what is the indicator used? Remember, in strong acid, strong base, and weak acid, strong base, the good indicator that can be used in both is phenol phthalate that goes purple in basic medium. Phenol phthalate. Practice writing the spelling of this indicator. Now, in strong acid and strong base, I can also use methyl red, but I do recommend to memorize this. Phenolphthalein, or we have bromothymol blue, we have phenol red. If you don't want to memorize a lot of names, just keep on this one. Now, moving to the next questions. These are titration curves. So indicate which titration is represented by the below curves. Now let's look at, I have here two titrations. The blue one, so I'm gonna change the color into blue, starts almost a straight line. Almost, or let me just say no jump at start. That's an indication that I have a strong acid. Second, it starts below zero. So for the blue one, there's no jump at start, and it's starting from a very low value of pH. This is the pH axis, and you go and you look for the middle of this one, and the middle of this one is exactly at 7. So the pH at equivalence, we call this equivalence point. The volume here is called volume at equivalence, and the pH 7 here is the pH at equivalence. So pH at equivalence is equal to 7. Therefore, the blue curve is the titration of a strong acid with a strong base. Be careful, if you wrote strong base with a strong acid, that is wrong. Okay? Now, the other curve. Let's look at the other curve. First of all, there's a jump. So there is a jump at start. Also, it's starting from above 2. That's another indication that this is a weak acid. And now let's look at the pH at equivalence point. Here's the pink one, and here's the middle. So I don't really care how much it is right now. I know it's 9, but all I need to know it is above 7. Therefore, this titration is a titration of a weak acid with a strong base. Again, if you wrote strong base with a weak acid, that it is wrong. Wrong to say strong base with weak acid, because the order here matters. Now moving on to another titration. Look at this titration curve. The equivalence point is at 7. So this is the titration of a strong acid with a strong base. The pH at equivalence point, the volume at equivalence point is 50 milliliter, and the pH at equivalence point is 7. Let's look at this other graph. There's a jump, and the pH in the middle is not 7. It's actually above 7. And it starts from high. So this is the titration of weak acid with strong base. Now, here's the equivalence point. Here's the volume at equivalence, and here's the pH at equivalence. Moving on to questions of subtopic 7.1. This is the topic where you are going to need or use the periodic table that you have over here. Now, for the questions of assigning oxidation number, you're gonna need the periodic table. Now, I'm just gonna explain to you a few tips about the periodic table. In determining the oxidation number of elements in compounds, elements in compound, hydrogen is always +1, and anything in group 1 will have an oxidation number of +1. Any metal belonging to group 2 will have an oxidation number of +2. Now, if I have an ionic compound, and the ionic compound is a combination of a metal and a non-metal, in this case, I can use the periodic table to determine the oxidation number of the non-metal. So group 17 will be -1. Now F is fixed. It's always going to be -1, whatever the compound is. O is always going to be -2, whatever the compound is. Now the rest might change depending whether it's the element to the right or not. Now, let's start. Okay. Determine the oxidation number, or assign the oxidation number of the underlined element in each of the following species. Now, they want us to calculate the oxidation number of Cl. Now, if Cl is on the right side, I would go to the periodic table and assign Cl a -1. But Cl is in the middle. So I don't know the oxidation number of Cl, and I am going to assign it as X. Now oxygen is always -2, except if it's an exception. And as we go through these questions, I will mention the exceptions. Now sodium belongs to group 1, so they have a fixed oxidation number to be +1. So we're gonna use this equation. +1 plus X plus I have 4 oxygen. Each one is -2 oxidation number. Now the overall charge of this molecule or of this compound is neutral. You see, an AClO4, there's nothing written over here, a plus or a minus. So you're gonna say equal to 0. Now in the examples like these ones, instead of saying equal to 0, you're gonna say equal to 1 or equal to -3 or equal to -2 or equal to -1. Solving for X, we will get X to be +7. So the answer is +7 for Cl. Moving on to another example. Again, this is -2. Aluminium belongs to group 13, so the oxidation number is +3. This is fixed. So I'm gonna assign P as X. So +3 plus X plus 4 oxygen, each one is -2 oxidation number. Solving this, we're gonna find that the oxidation number of P is +5. HNO2. Again, the oxidation number of hydrogen is fixed to be -1, and oxygen is fixed to be -2. So I'm going to assign this as x plus 1 plus x plus twice the oxygen equals 0. Solving this, we will get it as plus 3. Another example, n is x. I don't know it, but I know the h to be plus 1. So I'm going to say x plus 4 hydrogens, each one is plus 1. And this time, the answer is not going to be 0, it's going to be plus 1. Solving this, x would be -3. AsO4 3. So this is x and oxygen is -2. So x plus 4 oxygens, each one is -2, equal to -3. Solving this, x would be plus 5. Cr is unknown to us, oxygen is -2, so x plus 4 oxygens, each one is -2, and the answer is -2. Solving this, we will get x plus 6. NH3. So this is x, h is plus 1. So x plus 3 hydrogens, each one is +1, equals 0. The answer is -3. Now pay attention to this one. I have 2n. The elementary one is x. H is plus 1. So here we're going to say 2x because I have 2n. I'll put 2x, then I'll solve for 1x. 4 hydrogens, each one is 0. Solving for x, x will be -2. Last one, this is x and O. I'm gonna put it as -2 because O is always -2. So x plus 4 oxygen multiplied by -2 equal -1. Solving for this, you will get it as plus 7. Distinguish between oxidation and reduction in terms of loss and gain of electrons, in terms of loss and gain of oxygen, in terms of loss and gain of hydrogen, and in terms of the oxidation number. So here's the reduction and here's the oxidation. Reduction comes from the word reduced, becomes less. So the oxidation number in the reduction, oxidation number decreases in the reduction. So, and it's totally the opposite in the oxidation. Oxidation number increases in the oxidation. So for example, if I have Mg changed to Mg2 plus, this is 0, this is +2. So I'm going to say that Mg got oxidized. If I have I2 going to I minus, this is 0 and this is -1, there's a decrease. So I'm going to say that I2 got reduced. Now, in terms of oxidation number, this is done. Now let's discuss it in terms of losing and gaining electrons. Oxidation is a loss of electrons. We remove the minuses, that's why the oxidation number increases. Whereas in the reduction, it's a gain of electrons. Electrons are negative, so if I add negatives to an element, the oxidation number will go down, will decrease. So now loss and gain of electrons is done. Now let's discuss in terms of gain and loss of oxygen. Oxidation is a gain of oxygen, whereas reduction is a loss of oxygen. And I'm going to give you an example. If I have magnesium plus oxygen giving magnesium oxide, the oxidation, look at this one. Magnesium here is now coming with oxygen, so it gained oxygen. So that's an oxidation. Or if you look at the oxidation number, that's a 0, and here it's in a compound, it's +2. So it doesn't contradict with what we said. So if this is an oxidation, then loss of oxygen is a reduction. Now the last one in terms of losing and gaining hydrogen. I'm gonna give you an example over here. So let's say I have H2S plus Cl2. It's gonna give me S and HCl. If you look at this compound, sulfur was coming with hydrogen, and now sulfur lost the hydrogen. So a loss of hydrogen is an oxidation. Loss of hydrogen is an oxidation. If you want to look at the oxidation number, S here is -2 and here it's 0. So the oxidation number jumped from -2 to 0. So loss of hydrogen is an oxidation. Gain of hydrogen is a reduction. So here Cl2 was without hydrogen, now it's with hydrogen, gain of hydrogen. So we say that H2S got oxidized and Cl2 got reduced. Or you can just keep in mind that in the oxidation, we gain oxygen, but we lose hydrogen, and vice versa. Now, moving on to calculating the oxidation number of oxygen. Now, you know that oxygen, in most of cases, most of the time, has a -2 oxidation number. Now, if it's an elemental molecule like ozone or oxygen, it is 0. If it's in a compound, yeah, I mentioned it, it's H2O, for example. In a compound, it is -2. Now, in some cases, like in peroxides like H2O2, Na2O2, Li2O2, oxygen in this case is -1, and there is an exception for oxygen with fluoride. We're gonna calculate it. I know that this one is -1 and it will never change. So let's start. 0 is gonna be for the elemental form. So O3 is in the elemental form. That's a peroxide. And the oxygen in the peroxide is -1. Now this is just a normal compound, like any other compound containing oxygen, and it's going to be -2. Now let's look at OF2. O here is an exception. It's on the left side of the molecule. It is an exception. I don't know it. And F is always and forever -1 in compounds. So if I say X plus 2F equals 0, I'm gonna get oxygen to be, X to be +2. So +2 is for OF2. Basically, don't worry about these questions because there is no other option where O is +2 other than this exactly specific example. So there is no other example of O being +2 except this one. Now O being 0, it is either in O2 or in O3. O being -1, here's another example. You will always see it like 2, 2, like H2O2, Na2O2, Li2O2, let's say K2O2, it's a peroxide. And anything else, the rest in compounds, it's going to be -2. Complete the table by writing the species oxidized and the species reduced. So let's see this table. When they ask me about the species oxidized and the species reduced, the question is in the past, not the present. It's in the past. It means we are talking about only the reactant. You are not going to choose any answer from this side. So to say which one oxidized and which one is reduced, you're gonna answer from here. So that's the first hint I give you. Next, in order to know which one oxidized and which one reduced, compare the oxidation number before and after. And you don't have to do them all. If you know one, if you like guess one, like this is an oxidation, then definitely the next one is gonna be a reduction. So let me just put the lines here. Okay, now let's look at this one. Cl2 is 0, and now it's an ion, it's -1. The oxidation number dropped. So it means that Cl2 got reduced, therefore Br minus is oxidized. Don't forget to write the minus, or else we're gonna think that it's this one. Another example. This is 0 turning into +3, increased. It means that Ce got oxidized, therefore the second one is gonna be reduced. And look at it, it's +2 turning to 0. Cu2 plus. Now this is very important, and I'm gonna say it again. If you accidentally write Cu, this is wrong, because it's not this one, it's this one. Again, another one. This is 0, oxygen in the compound is -2. Always select the elements that you know them. So oxygen got reduced, so O2 reduced, Zn oxidized. This one is easy. That's a +1, that's a 0. Reduction. So H plus reduced, Na oxidized. Last one I have here. H in a compound, it's going to be +1. H in an element, it's going to be 0. So HCl reduced. So you can either say HCl, or you can say H plus in HCl got reduced. Okay, so both of them are correct, and this is zinc oxidized. Now, there will be definitely a question in your exam asking you which one oxidized, which one reduced, which one is going to be oxidizing agent, and which one is going to be reducing agent. Now, you're going to flip it like that. The species oxidized are called reducing agent. Memorize this, reducing agent. Don't just say reducing, it's reducing agent. And the species reduced are called oxidizing agent. So, when they ask me about the oxidizing agent, it's the species that got reduced. And the reducing agent, it's the species that got oxidized. So again, I'm gonna solve it the same way of the previous question. This is 0, elemental form. This is group 2 in a compound, it's +2. So Mg got oxidized. Mg got oxidized. So Mg is the reducing agent. Again, you never choose from here. Never. Now, if Mg oxidizing agent, reducing agent, then I2 is the oxidizing agent. Again, that's a 0 elemental form, and that's a +1. So H2 got oxidized. It's a reducing agent, N2 reduced. Now, writing half reactions, oxidation and half reduction reaction for a redox reaction. First of all, you split the equation into two half equations. Hg2 plus turning into Hg, and Cr turning into Cr2 plus. Remember, in the oxidation half reaction, the electrons are written after the arrow because they are lost. And in the reduction, the electrons are written before the arrow because they are gained. So over here, I have a +2 charge, and here it is 0. Always we add the electrons on the higher side. So I'm gonna add electron over here, 2 plus and 2 minus is gonna be 0, and that's 0. So this one is now balanced. If this is the reduction half equation, then the other one is gonna be the oxidation half equation. So I have here neutral, 0, and I have here plus 2. So I'm gonna add 2 electrons on this side to balance the charges. Use the following redox reaction to answer questions 53 to 55. Identify the species that oxidized and reduced. This is from 0 going into plus 2. Oxidized. So Mg oxidized and H plus reduced. Write the oxidation half and reduction half reaction. So the oxidation half reaction is Mg turning into Mg2 plus. Again, I said oxidation, the electron is after the arrow, 2 plus, 2 electrons. The reduction half reaction is H plus giving H2. Now be careful, I have 2 hydrogens, so I'm gonna write 2H plus. I'm just explaining this just in case in the exam they didn't put the 2 here for you. So now this is 2 plus, I'm gonna add 2 electrons. I will explain this and keep it in mind. For example, if I have A3B minus 2, and let's say there's a number here. This coefficient, you should multiply it by everything. So if I'm counting A, I have 2 times 3, I have 6A. If I'm counting B, I'll say 2 times 1, I have 2B. If I'm counting a charge, I'm gonna say 2 times the negative 2, and that is negative 4. So therefore here, when I have 2 hydrogens, I place 2 here. But when I was counting the charges, I must not forget 2 times a plus, that's a 2 plus, 2 minus, it's a 0, in order to be balanced. Write the oxidizing agent and the reducing agent. So Mg is oxidized, so Mg is the reducing agent, and H plus is reduced, so H plus is the oxidizing agent. Next, moving on to subtopic 7.2, and this is where you have a little bit more complicated balancing. I'm gonna give you these tips. Whenever you want to balance a redox equation reaction in acidic medium, start by balancing elements. Balancing elements, not hydrogen, not oxygen. You balance them by adding coefficients. Then after balancing the element, you move to balance O by adding H2O as much as needed. 1, 2, 3, 4, as much as you need in order to balance the O. Then you balance the hydrogen by adding H plus. Again, how much you need? 2, 3, 4, etc. You put it like this. And finally, you balance the charge by adding electrons. So let's first begin with this one. I'm gonna split it into 2. ClO3 minus giving me Cl minus. First, I'm gonna start 1 Cl, 1 Cl, balanced. Next, 3 oxygen. As I said, I balance oxygen by adding H2O as much as needed. So I'm gonna need 3 H2O. Now remember, whenever I have a coefficient, I multiply this coefficient by, if I have here 2, as I said, 2b or 6a. So In here, I placed 3H2O. It means I have 6 hydrogen. So over here, I'm gonna add 6H pluses. Now we reached the charge. Don't forget to multiply the number by the charge. I have 1 minus and I have 6 pluses. So I have a total of 5 pluses. Use this method, draw the pluses that you have. So 1, 2, 3, 4, 5. On this side, I only have a minus, and this is 0. Balancing the charge is done by adding electrons on the higher side until it reaches the lower side. So for this one, if I'm gonna add 1, 2, 3, 4, 5 electrons, it's gonna become 0. I don't want it 0, I want it -1. So in this case, I'm gonna add 6 electrons. So 6 electrons will be added on this side. I'm done with the first one. Now I'm gonna move to the next one. SO2, SO4, 2 minus. 1S, 1S, balanced. 2O, 4O. I'm missing 2 oxygens on this side. 2 oxygens. So I'm gonna add 2H2O. As I said, you balance O by adding H2O as much as needed. Now, when we reach hydrogen, don't forget to multiply the hydrogen by the number here. So 2 times 2, that's a 4 hydrogen. So I'm gonna add 4 H pluses here. Now the charge here is nothing, 0. The charge here I have 2 minuses and I have 4 pluses. So it means I have 2 plus here for 0. 2 plus for 0, I'm gonna add 1 minus, 2 minus. I'm gonna add 2 electrons in order to get 0 on both sides. Almost done. Now, what's the next step? The next step, you're gonna add the half reduction with the half oxidation. So, but you need to make the number of electrons lost and gained equal. Here I have 6 electrons gained and 2 lost. So I'm gonna multiply this whole equation by 3 so that I have 6 gained and 6 lost. And I'm going to write the overall. So 6 electron, you see, here are the arrows. I'm gonna write everything here before the arrow and everything here after the arrow. So 6 electron plus ClO3 minus plus 6H plus 3SO2 and 3 times 2, 6H2O. 6H2O. Now I'm done. I'll continue. I have Cl minus and 3H2O and 3SO4, 2 minus, and 3 times 4, 12H plus, and 3 times 2, 6 electrons. Now, this is almost the last step. After you write this, do not forget to cancel out the common substances. So, I have here 6 electrons, they cancel out. I have 6H plus with 12. So from the 12, I have 6 left. I have 3H2O and I have 6H2O. So from the 6H2O, 3 are left. And now you can write your final answer to be ClO3 minus plus 3SO2 plus 3H2O giving Cl minus and 3SO4 2 minus and 6H plus. That's the final answer. Now, another question. Given the following redox, write the reduction, write the oxidation. Just look at it. Find the easy one. That's a 0, that's a +3. So Fe got oxidized. Fe to Fe3 plus. This is 0, this is 3 plus. I'm gonna add 3 electrons. If this is oxidation, then this one is the reduction, Mn2 plus. Now I have 1 Mn, 1 Mn, balanced. Next thing is the oxygen, 4O, so I'm gonna add on this side 4H2O. By adding 4H2O, now I have 8H. So I'm gonna write here 8H plus. Now, I'll count the charges. 8 plus and 1 minus, here's I have 1 minus, it's gonna be 7 plus. So I'm gonna draw 1, 2, 3, 4, 5, 6, 7. On this side, I only have plus 2. How many electrons I need to add on this side to make them equal 2 plus on both sides? So I'm gonna cancel out 3, 4, 5 and keep 2. So 5 electrons. Here we go. We're done. When they tell you write the overall redox, you're gonna add both equations. But this one lost 3, this one gained 5. So you must multiply this by 3 and this by 5 to make the loss and gain of electron equal. And then you write it all down in here. So 3MnO4 minus. And then 3 times 8, 24H plus. And then 3 times 5, 15 electron. I'm not done yet. I need to also take this side. 5 Fe. Now I'm done. I'll put the arrow. 3 Mn2 plus and 3 times 4, that's a 12 H2O. That's a 5 Fe3 plus and 15 electrons. Then we cancel out the common things. Electron, they should be cancelled. Yeah, that's it. Nothing to cancel because here I have H2O, I don't have H2O here, so I cannot cancel it. Same thing, I have H plus, but no H plus here. So that's the final answer. You can copy it again without the electrons. Plus 5 Fe, giving 3 Mn2 plus 12 H2O and 5 Fe3 plus. And that's it. Moving on to subtopic 8.1. Identify the components of identify components and label a voltaic cell. So here I have a voltaic cell. This is the voltmeter, the one that's going to give me the voltage of the battery. Now these pieces of metals are the electrodes, and I have two types of electrodes. I have the anode and I have the cathode. Always the anode is the negative electrode in the voltaic cell and cathode is the positive electrode. Anode is the electrode that lose electron. Cathode is the electrode that gain electron. Anode is the one that decrease in mass and cathode is the one that increase in mass. Now, anode has the most reactive metal. Cathode doesn't have. Towards the anode from the salt bridge, here's the salt bridge. In the salt bridge, I have positive and negative ions. The negative ions in the salt bridge migrate towards it. And the positive ion of the salt bridge is going to migrate towards the cathode. So I'm going to write it here. Positive ions migrate towards it. So yeah, here we go. Now look at this battery. I have here a sign showing me that the electron are leaving this electrode, coming to this electrode, which means that this is the anode and this is the cathode electrode. This is the salt bridge, and the cathode the cathode is the one that undergoes reduction and contains in here the oxidizing agent. So let's say if this is copper, this is gonna be Cu2 plus. Cu2 plus is the one that's gonna catch up the electrons to give me copper. And this is the solution containing the anode ions. So I have here an oxidation, and this one will contain the ions, of the anode, because the metal is going to oxidize into ions. So this one is going to contain the ions of the anode, or you can say solution of anode, or anode solution. Even here, if you forgot about containing oxidizing agent, you can say contain solution of cathode. Now here's the salt bridge. Let's say I have an ACl. An A is positive, Cl is negative. The positive ions in the salt bridge, they go towards the cathode. So you're gonna see an A plus moving on towards this one, to the solution. And you're gonna see the Cl minus moving to this side towards the anode solution. Last thing, the transfer or the movement. Electrons, they move externally from anode to cathode, from the anode towards the cathode. Whereas the current, it moves also in the circuit, in the electric wire, and it goes from cathode to anode. The ions of the salt bridge, they move internally through the salt bridge. Now that's a lot of information. Pause the video and repeat at least 2 times to remember it. Moving on to the next question. A galvanic cell operates spontaneously. So first of all, they told me I have a galvanic cell, also known as voltaic cell. Operates spontaneously. Spontaneously means that the E cell is going to be positive. The voltage of this cell is going to be positive. And it consists of 1/2 cell that contains silver metal and silver ion. Here we go. Here's the voltage. And another half containing copper solid and copper ion. Usually, the equations are provided to you in the exam, but both of them are written in form of reduction. It's up to you to keep one reduction, and you're gonna know which one I must flip into oxidation. Then they tell me what species are produced at the electrodes under standard conditions. Now, because it is a voltaic cell, we're gonna look at the voltages. The higher voltage will be cathode. So here's the cathode, and the lower voltage is the anode. So that's the anode. So I'm gonna keep this as a reduction, and this one I'm going to flip it, and I'm gonna write C solid giving Cu2 plus 2 electrons. So these are my two equations taking place at the anode and at the cathode. Now let's read the question. AgAQS, a metal and it's aqueous. I'm not gonna continue reading this sentence because I cannot have a solution without a charge. It should be Ag plus. So they told me Ag, that's wrong, out. Copper solid is formed. Copper solid is not formed. Copper solid reacts to give me copper aqueous. Copper solid is not formed. Copper solid is consumed. I'm not gonna continue reading this sentence. Cu2 plus is formed. Yes, Cu2 plus is formed at the cathode. No, it's formed at the anode. So this one is wrong. Now that leaves me with this option. Ag solid is formed. Yes, I obtained Ag solid at the cathode. True. And Cu2 plus aqueous, here you go, is obtained at the anode. This is the correct answer. Next, a voltaic cell operates spontaneously. So again, they've told me that this is a voltaic cell. So I'll tell you, I look at the voltages. The higher voltage is the cathode, the lower voltage will be the anode. Now they want to know which one is the anode, which one is the cathode. So that's the cathode. Now are you going to answer this or this? Remember, these two are electrodes. Cathode and anodes are electrodes. And electrodes is a metal, not an ion. So I'm gonna choose from these two. So the cathode is zinc and the anode is Cr. If by any chance you're gonna write Zn2 plus, or you're gonna write here Zn2 plus, that's wrong. Cr2 plus, that's wrong. So remember, do not write these two as your answer. Take the metal because electrode is a metal. Write the overall equation for the reaction in the above question. The overall equation. If that's the cathode, then this equation is not going to change. The Zn2 plus 2 electrons giving zinc, well, I will not flip it. This is a reduction. But for the anode will undergo an oxidation, and here it's written in form of a reduction. So we're going to flip this one. So we're going to say Cr giving Cr2 plus and 2 electrons. 2 electrons gained, 2 electrons lost. I can simply add them. And the overall is Zn2 plus. Don't forget to write the physical states. Anything that has a charge will take AQ. Anything without a charge will take solid. So Cr solid, Zn solid, and Cr2 plus aqueous. Next, a voltaic cell operates spontaneously with magnesium as anode. So magnesium is going to get oxidized, meaning from Mg to Mg2 plus, oxidation. Oxidation number will increase. And Cu as a cathode to Cu2 plus, meaning from Cu2 plus, that's a reduction to Cu. Write the oxidation and half reaction occurring at anode and cathode. So at anode, I have an oxidation. And the oxidation will be as follow. Mg giving Mg2 plus and 2 electrons. And at the cathode, I have a reduction, and the reduction will go as follow. Cu2 plus 2 electrons giving Cu solid. Calculate the electrochemical cell standard potential of a voltaic cell with overall reaction below and is redox reactions spontaneous or non-spontaneous. Now, to be spontaneous, the E cell is going to be positive. Non-spontaneous, the E cell is going to be negative. But there's a hint in the question. They told you a voltaic cell. So for sure, this one is going to be positive. Now, what if this was not mentioned in the question? What am I going to do? How am I going to know which one is oxidation and which one is reduction and determine if it's spontaneous or not? I'm going to look at the equation given. This is 0 going into +2. So that's the anode. That's the anode. And this is taken as cathode reduction. Therefore, I'm going to calculate E cell. E cell, the formula is in your formula sheet. It's E cathode minus the reduction potential of anode. So it is 1.07 minus negative 0.13, and that is 1.2 volt. Now this value is positive. You're going to say spontaneous. Now finally, the last topic, compare between electrolytic and voltaic cell. An electrolytic cell, I'm going to write here electrolytic and here voltaic cell. And I'm going to compare everything between them. So first of all, let's start with the main things. Electrolytic cell starts with electrolysis, electric. So it converts electrical energy to chemical energy. Voltaic is the opposite. It converts chemical energy to electrical energy. That's one. Next, electrolytic is a non-spontaneous cell or redox reaction. And this one is a spontaneous redox reaction. Next, in the electrolytic, the voltage is negative. In the voltaic, the voltage is positive. Now, in the voltaic, the anode is the negative electrode and the cathode is the positive electrode, and that's different. Here, the anode is the positive electrode and the cathode is the negative electrode. Next, this one requires a power source like a battery. This one do not need a power source. What else? Now, common things between the two: electrons go from anode to cathode and current from cathode to anode, and it's exactly the same. Electron from anode to cathode and current from cathode to anode. These are the main things that we can compare. Explain using diagrams again the difference between a voltaic and electrolytic cell. And I think that's it. I mentioned everything in it. Now I'm just gonna the figure written in the focused questions is showing exactly all the differences I mentioned over here, except that in the electrolytic cell, if I have the electrodes, if this is the anode, and this is the cathode. I'm talking about electrolytic, and here's the medium. There is no salt bridge, but the positive ions are going to gather around it, and this one, the negative ions are going to be attracted toward the anode to get oxidized, and those are going to be attracted toward the cathode to get reduced. And that's it. All the best in your end of year exam.